Okay, today we're going to continue with our polynomials. So now we're going to learn about multiplying polynomials. We're only going to multiply polynomials by monomials. So we're only going to use one single term to multiply through. And what we're going to do is we're going to use something called the distributive property. And the distributive property is something we actually saw very briefly in the last lesson when we were discussing what to do with that negative sign in front of a bracket. So we're going to formalize that with the correct vocabulary this time and call it the distributive property. So with the distributive property, we're going to be expanding brackets by multiplying through the monomial by every term in the bracket. Okay, by every term in the bracket. And does this work? Yes. So again, I can show you using whole numbers. So we could say 2 times 3 plus 3. And if we're following the rules of Bedmas, we'd say that's going to be 2 times 3 plus 3 is 6, and that's going to be 12. Okay? If we just multiply the 2 by the very first 3 and ignore that, basically removing the brackets, we'd get 2 times 3 is 6, plus 3 is 9. We would not get 12. But if you multiply the 2 by every number in there, okay, you get 2 times 3 plus 2 times 3, which is going to give you 6 plus 6, which is going to give you 12. Notice that those are the same. Okay, so that's the correct way to take the brackets out when you've got a multiplication question. So let's look at our very first example. Okay, right there, 2x times, all in brackets, 3x plus 8. So we're going to bring in our exponent rules. We're going to bring in all the things that we've been working with over the last couple lessons. And we're going to say 2x times 3x. So if you just pretend that's all you got, 2x times 3x. What is x times x? X times x is x squared. And what is 2 times 3? Well, 2 times 3 is 6. So 2x times 3x is actually 6x squared. So that's 2x times 3x. But I'm not done. I have to go through the whole bracket, so I'm going to apply the 2x to the 8 as well. So 2 times 8 is 16, and I have x times nothing else, so that's just going to be 16x. Okay? Let's look at the next one. I have to expand to every term inside the bracket. So I've got a monomial in front of the brackets. Inside the brackets is a binomial. So I'm going to have to multiply the monomial by each term of the binomial. So negative x squared, that's the same as negative 1x squared. So what is the negative 1 times 5 is going to give us negative 5. X squared times x. Well, x squared is x times x. So it's x times x times x. So that's going to be x to the exponent 3, or x cubed. And then we have a negative times negative 13. What happens when you multiply a negative by a negative? It becomes positive. And negative 1 times negative 13 is positive 13. So that's what we're going to get for the integer, is positive 13. The x squared, there's no other variables in there, so that x squared is just going to stay x squared. So negative 5x cubed plus 13x squared. Now we're going down one. And now we have a trinomial. We're multiplying a monomial by a trinomial. So now instead of multiplying the 3x twice, we're going to multiply the 3x 3 times. So 3x times x squared is 3x cubed. That's this multiplication right there. Okay, the integer in front of the x squared, because it's not there, we can safely assume that it's 1. 3 times 1 is 3. X times x squared, we add the exponents using the exponent rule for multiplication, and 1 plus 2 is 3. Let's look at the next one. 3 times 4, 12. X times x, x squared. And one more time, we're not done. There's one more term in that bracket. Negative 11 times 3 is negative 33. And we've got one x involved, and there is our final answer. It's not so bad. Let's, just for fun, try this last one. This last one is a doozy. It is as complicated as you are going to see in this lesson, though you might see more complex as we practice throughout the lesson to come. So what do we have here? We have 1, 2, 3, 4 terms. So it's going to multiply 4 times. And now not only do we have 4 terms to multiply, but we have different variables. We have x's and y's. So now we're going to have to be very, very meticulous and very careful about how we go about this. So let's start with that very first one. 3 times negative 1 is negative 3. X squared times x, x cubed. Y times y squared is y cubed. They're all multiplying each other. That actually says negative 3 times x cubed times y cubed. Then we'll move to the next one. 3 times positive 4 is plus 12. X squared times x, we've got x squared times x is x cubed. Y times y is y squared. There's only 2 y's. The third one, 3 times negative 6 is negative 18. X squared times x is x cubed. Y, there are no other y's, so that y carries through. It's y to the exponent 1. We're almost there, guys. One more term to multiply through. 3 times 3 is 9. X squared, there's no x's in the second term, so it stays x squared. Y times y squared gives us y cubed. Now I want you to look at it and ask yourself, is there any more simplification that we can be doing? Can we add any of them or subtract any of them? And what you're checking for is, are there any like terms? So let's take a look. We've got x cubed, y cubed. Are there any more x cubed, y cubes? No. X cubed, y squared? No. X cubed, y? No. And x squared, y cubed. They're all different combinations of those exponents on the variables, so we cannot simplify any further, and that is our final answer.